You're listening to Snyder & Associates podcast series, a civil engineering, planning, and design firm focused on thinking beyond engineering to improve quality of life within the communities we serve. This episode's hosts are Patrick Williams and Wes Farrand.
Well, today we're talking about limiting impacts through trenchless technologies. This is focusing primarily on municipal infrastructure, water, wastewater infrastructure, and how we can limit impacts when it comes to new construction and also rehabilitating old systems as well. My name is Wes Farrand. I'm a senior engineer with Snyder & Associates out of Ankeny, Iowa. I've been working in the water, wastewater business for a couple decades now. I've done quite a few projects of these natures, and today we're going to talk with Patrick Williams out of our Cedar Rapids office, and I'll let him introduce himself.
Yep, my name is Patrick Williams. I'm a civil engineer in Cedar Rapids. I've primarily done projects in water mains, sanitary sewer, and treatment plants, and a lot of those projects do involve the trenchless installation of pipes. So I'm here to help talk about my experiences with that.
Yeah, very good. And I would say it sure seems to me like the trenchless aspect of the construction and the infrastructure business is increasing. We seem to see it a lot more and more lately. I think for good reason. It has some positive benefits and some aspects of it that make it appealing, both financially and some of the intangible things. I don't know, Patrick, in your experience, are you tending to see more of it than what we used to see in the past?
I would say we are seeing more of it because as time goes on, there's more and more infrastructure above ground being built. And when you're putting pipelines in these areas that are already established, you don't want to tear all that up. So we go with the trenchless because it limits the disruption above ground and keeps the pipe underground without excavating recently paved streets or railroads and such. So yeah, as areas are getting more developed, trenchless is becoming more necessary to use as a method of pipe installation.
Yeah, that's exactly right from what I understand too. And also I think in the recent years, just the technology has improved quite a bit. There's more and more technology out there. There's more and more people using the technology. So that's really helped the prices come down to where we've had some bids where we had some trenchless and some open cut trenched water main, similar sizes. And the trenchless was actually cheaper foot per foot, not even considering all the intangibles of the driveway replacement, street replacement, just because the ease for the contractor. And so he was able to tunnel it in cheaper than anybody could dig it in. So I think that's probably what's contributing a lot to the more prevalence of it. When it comes to the construction industry and infrastructure, the adage of you have to break a few eggs to make an omelet couldn't be more true, because when we go to do a project, we mess things up pretty good. We're digging, we're making a mess, we're piling things up, we're breaking things before we can put it back new and good. And so when it comes to impacts of a construction project, it can get pretty extensive, especially like you said, when we're in an area that's built up and things are real tight and close. And so the ability to do the work we need to do without digging can be a huge benefit to the community and the people adjacent to the project.
In addition to the minimizing site restoration needs, such as like paving or habitat restoration, I've also seen like public view on projects change for open cut versus trenchless. When you're putting a pipe in someone's backyard and you have a big open cut trench and their backyard's getting torn up, we tend to get a lot more calls from the public asking what's going on, when is it going to get fixed, why is no one working? And even though, they're working at a perfectly reasonable pace, but when we have trenchless, those calls seem to decrease. There's less traffic noise and pollution, et cetera, when you go through the trenchless method as well.
Yeah, and that's exactly right. I think that's some of the intangibles that should be factored in, the PR cost savings, even just the right-of-way acquisition from the property owner.
Do we want to talk about cons?
Sure, yeah. What cons have you run into, Patrick?
I'd say the most common con of using trenchless from a client standpoint is the cost.
Yeah.
Pipe materials, for example, like an 8-inch water main open cut, maybe 5 years ago, you'd be looking at $20 to $30, $20 to $40, depending where you are, per linear foot of water main. And then when you upgrade that to trenchless and even further trenchless with a casing pipe, you're looking at like $100 plus per linear foot. So while trenchless does have a lot of benefits in terms of rehabilitation, it is worth understanding that if you did your whole project trenchless instead of cutting in some trenchless with some open cut, you'd be having a much more expensive project for the same end result of having a pipe in the ground. It is prudent to choose those areas wisely. Use your existing survey of, we know this area is dense of utilities. We know that this road is driven a lot. Let's not disturb it, but not just go through an open field trenchless because you like watching the machine run.
Yeah, you're exactly right. You do pay for what you get. So it has to be weighed in, both the monetary and the non-monetary benefits to it, right? Because you're right, it is 2 to 3 times more expensive, or even more depending on the size that you're getting to. Now, I will say on the rehabilitation side, it's about 2 to 3 times cheaper to do a sewer lining versus reconstructing the whole sewer. So on the rehabilitation side, the advantage is, the money advantage side. I think the cons on the rehabilitation side for the trenchless rehabilitation, it does extend your sewer life. It might not be as long as the brand new sewer, but it might be. The problem is we don't have 50, 100 years of some of these new liner technologies in the ground. So there's a little bit of risk there on how long it'll last. The other con that can come up with trenchless too is you want to think, oh, there's just no impacts. And then there are some impacts, especially with a new construction. You do have entry and exit points you got to deal with. So there are some impacts.
Another conflict is unknown utility. Sometimes there's unknown stuff in the ground, such as large boulders, existing utilities that have been in there for a long time and just no records were provided during design and the contractor bores right through it. So that's always a possibility and a risk. If you hit something 200 feet into your bore, that's going to cause the whole project to kind of stop and you're going to have to investigate what that utility is. Hopefully it's something that you can deal with quickly, but if it's a major sewer, you're going to have to go back and re-bore it to avoid that utility conflict. So those are just risks, not necessarily a con that you're going to run into every time, but it's kind of a gamble when you're boring underground that you're not going to hit something crazy.
Yeah, you are right. It's a risk that you can't see what's ahead of you. If you can open cut, you can usually see that and can deal with it. But with trenchless, there's always that risk.
Well, that kind of reminds me of the idea of unknown conflicts. We had a Cedar Rapids sewer project where we were going under a roadway that there's an old landfill and there was a bunch of stuff buried under the road. And the joke during design was, hopefully we don't hit a car. We just weren't sure what was under there. And we were about 50, 40 feet under the roadway, but there was no car.
Yep. Like you said, nobody had any idea they were there. So there's always that risk. That is the con, I think, to trenchless. But I think the benefits outweigh, but you just have to be flexible at the back end. And I think probably going to talk to that a little bit, part of the upfront that you need to take into account when doing a trenchless project is it takes a little extra level of due diligence to research and figure out what utilities are there and do some test holes, kind of a hydro excavation to identify the exact location of some of those other pipelines or to determine that it's clear. Okay, so trenchless has a pretty wide range of technology and applications, and we've touched on a little bit where there's trenchless new construction and there's trenchless rehab. They're really different technologies, but both of them have that goal of limiting the impact to surface features and avoiding conflicts. So we'll get into a little bit into some of the new trenchless technologies and options that are out there. Probably the most common that we see is the horizontally directionally drilled trenchless. They send a pilot bore through and then they back ream and pull the pipe in from the tail pit up back where they started. This is something that's primarily used for force mains or water mains. The grade control is not quite as precise in my experience and in most recommendations and guidelines. But for the force mains and water mains, it's really handy. It doesn't require a casing pipe. They can pull directly in the main carrier pipe. And this is what we see a lot for water mains and force mains. And I think, Patrick, you've used HDD on a few things before, haven't you?
Oh, yeah. I've done several projects using the HDD. And kind of what you were saying, it's not a direct straight line that can kind of go up and down and to the side. So you kind of got this weird shape that avoiding whatever existing conflicts underground may be or getting under, a culvert. I know on one of my projects, there was a 18-foot deep and 40-foot wide box culvert that was at a creek. And so our water main was supposed to be generally about 6 feet underground, but we really had to go deep to avoid that and go directly underneath the culvert. So the contractor set up his bore machine on one end and just kind of did almost like a U shape and got like 60 feet underground with that water main to the other side and pulled that water through with some PVC pipe.
Yeah, that's probably where I've seen the biggest advantage and shine is under creeks and drainage ways and under box culverts and things where if you had to dig that up to get the depth you needed to get underneath some of those drainage ways, or just like the advantage of be able to go deep with it when you had to is pretty handy.
Yeah, and they also have a sensor at the tip of their bore. So
Yeah.
they're able to get a 3D report. So when you're doing your as-built drawings, you're able to provide accurate horizontal and vertical location information of where that pipe actually is underground.
Yeah, and there's some steerable capabilities to that as well that makes it pretty handy for both vertical and also a little bit of horizontal. We had one where they were able to take some horizontal alignment changes to avoid an intermediate pit or open cut construction on a project and just keep boring through because they were able to deviate horizontally and track that. I think probably the con or risk with the HDD is it doesn't really like different soil materials, and soil testing is a big thing to make sure that you've got some investigation done there to know what you're digging through. When you have to go from maybe a sand into a bedrock, that causes problems. From what I've been told and seen, if you're going from sand to bedrock, more than likely it's just going to bounce along the top of the bedrock. They have to use different cutter heads, and it doesn't really like to make that transition. You can bore through rock and you can bore through sand, but doing from one to the next can cause issues. I don't know if you've ever run into that, Patrick.
The only issue I've really ever seen on HGD method was we were boring in a 12-inch force main in Anamosa, and they pump in this lubricating gel to allow the pipe to slide in. There was something wrong with the soil where we were going, and there's bore gel spilling out of the crack between the curb and the asphalt roadway. And okay, we need to get filter socks down on that. But generally, it's always a pretty smooth process. But every now and then, yeah, you get weird soil conditions, and it gets some unexpected results.
No, you're right. The drilling fluid that they use for that, yeah, there's a science and an art to that. Here in Iowa, where we have pretty heavy clay soils, that generally helps us because that drilling fluid is contained within the clay that we're boring through, so it doesn't really blow out too often. But you get a sand seam or some kind of different soil interface, and yeah, if you're running too high pressures, the path of least resistance, it's going to squirt out. So that is something to keep in mind. You're right. Another technology that I want to touch on a little bit is the auger bore. That's a casing pipe with an auger soil removal down the middle of the casing pipe. Patrick, have you had experiences with auger boring?
From what I understand, the auger is just a big screw.
Yeah. They actually have to dig down a jack pit, and they dig down a tail pit or receiving pit. And then they set up rails and a push system that pushes the casing pipe in. The auger in the middle of the casing pipe pulls the material out. They drive the casing pipe through. Your receiving pit is a lot smaller for this because it's basically just the open cut trench that you're going to keep going with your pipe on the far end. Your bore pit tends to be a little bit bigger impact, so that's something that we have to watch out for. Make sure you got the footprint to be able to drive that in, but they can hold pretty tight tolerance grades with auger and auger boring in that casing pipe. And then they run the carrier pipe through the casing pipe with spacers and whatnot. That one's pretty common around here. We see this a lot for sewer construction. A carrier pipe can be any pipe material. It can be the same pipe material. You're running open cut on either end, so it can take any kind of carrier pipe and pretty foolproof. That casing pipe will hold your tunnel hole, which is kind of nice. If it's a large enough tunnel, and we had one that was going underneath the railroad, that was a 72-inch diameter pipe. So the casing was 96-inch, so you could walk in it. So if you had to remove cobbles at the face of that, you could go in there and remove cobbles to some extent up there. It does have a little bit of the risk taken out of that because you can pull the guts out of the tunnel and access it to address anything you might hit. They can change augers from rock bit to a soil bit to some extent, so it gives some flexibility. Another one for new trenchless is microtunneling.
When it comes to microtunneling, essentially you have a large machine that pushes the steel casing pipe inch by inch. It pushes the pipe, goes back, they add more pipe, and it keeps pushing it under. And at the head of that pipe, they have a machine with a bunch of digging gears that rotates and upsets the head of the bore, and they're able to remove the material that's in the way in their large tunnel.
Most people think of this when they think of the English Channel. That was a giant one. They make those on smaller scale too, same kind of thing. Sometimes they'll pilot bore a small pipe through and then the PBM or the microtunnel machine will follow it. Sometimes it's on line and grade with a jack system behind it pushing through either casing pipe, or you can use this to direct jack. Storm sewer concrete pipe can be used to direct jack with this, where you don't have to have a casing pipe. We did this with a 72-inch concrete sewer. So 72-inch pipe to put in a steel casing, that's a pretty big casing, adds quite a bit of cost. So being able to get a little bit beefier concrete pipe and then jack it directly in, was able to save some cost there, and it had some options. Patrick, have you used this microtunneling of any scale on a project of yours?
Yeah, one of my first projects was a 66-inch diameter trunk sewer through Cedar Rapids, and we had about 400 feet microtunneled under Iowa 380 highway. but we were able to avoid any disturbances on the most traveled road in Cedar
Well,
Rapids. So
yeah, but going back to kind of what we talked about before, that's expensive for pipe, but it doesn't factor in what it would cost in traffic control and diversions and detours and headaches for all the thousands and thousands of travelers that use 380. The cost definitely was taken into account, I'm sure, on what the other impacts would have been for that project.
yeah, it was definitely one of the coolest projects I've worked on, because mostly what we work with is like 12 to 24 inch pipe around there, and 66 inch presented some interesting challenges with the trenchless because there's a lot of stuff you can hit.
Yeah, those are really neat projects when you get to that size.
One other thing when you're considering trenchless installation of pipe is the application of the pipe and the material of the pipe. Typically, when you're dealing with water main or sewers, PVC is the most common material, but I've been recently using a lot of HDPE on different projects because of its bending flexibility. Normally if you have a bend in a water main or a sewer, you can either put the sewer at a manhole or you can put like a 90 or 45 degree fitting. But sometimes that isn't necessary, and you can get the HDPE material, which has a really tight bending radius, and you can really bend that pipe around at a lot of crazy angles. And when you're doing trenchless, if you have to add a manhole or a fitting, that's just another open pit that you're going to have to do. So if you're able to do all those bends all underground, all trenchless, it can save a lot of time and money for the project overall. But if you're trying to do sewer, especially gravity sewer, you really want to stay away from any bends. You really want that pipe to be straight. But when you're talking about pressure pipe, like a water main or a force main, something that's under pressure, you can get a little bit more creative with the alignment of the pipe. HDPE has just been a fun material to work with because it's less rigid in the rules that you typically have to follow when you're doing a concrete or a ductile iron or PVC pipe. PVC pipe is flexible, but only to a fault. I think you get like maybe a few 100 feet of bending radius before that thing will burst underground and you'll have to go dig it up and replace it. But yeah, HDPE, it's the way of the future. So we were just talking about new trenchless insertions, which is virgin soil, a new pipe going in, brand new, everything is different. Now I kind of want to transition to rehabilitation of existing infrastructure with trenchless technology. And there's a couple different ways we can rehabilitate a pipe through trenchless, one of that being slip lining. What's your experience with slip lining, Wes?
Slip lining has always been one of those things that we evaluated as one of the potential options, but on most cases that I've been involved with, it turns out that it doesn't end up being the preferred option. The pros of it, obviously, is it's trenchless for the most part, but the cons, it does require an excavated pit to access the pipeline to be able to put the slip lining pipe in and push it through the pipe. And generally where we've been evaluating it, other technology or options have better pros, if you will. So while we always look at it as an option, it's not one that we typically get into as the actual final solution that's been used, but it does have its application.
Can you briefly explain what slip lining is?
Oh yeah, sure. So slip lining is where you take a slightly smaller diameter pipe than the pipe that you're going to rehab, and you make an excavation down to the existing pipe, cut into the existing pipe, and then you push the new smaller pipe inside of the old pipe, and it lines the inside of the pipe with this new one inside. And so you drop a piece in, you push it down, you connect the next one to it, push it down until the pipe is lined, and then you patch the hole where you cut in and backfill your excavation and get out. So that excavation tends to be what slips this one out, but it does have its place and it can be used effectively. Probably its best application is where you don't have any connections and it's a long straight run. You get into too many bends and it doesn't work if you have to do any service taps. So small diameter stuff, it doesn't work for so well because there's better options and you have to dig up every place where you have a connection. So that kind of drives it out. But long straight runs, large diameter pipe. Pro that I've seen is it can be done under some live flow, which when it comes to doing any kind of sewer rehab, bypassing and dealing with the existing sewer flow is always one of the big things that's often forgot about, but it's almost always a big factor and it can be a big cost too. It's not like you can tell the whole town just to, hey, stop flushing for a day or two, would you? So slip lining can be done under some flow, which can help.
I would also think you're putting in a smaller pipe, you're also lowering the capacity of what was existing to a certain extent.
Yeah, a little bit. And that's something to take into account. Now, sometimes you can accommodate that with the different Manning's coefficient, which is basically the smoothness of the pipe. A rough pipe is going to be able to carry less flow than a smooth pipe just because of the friction and the resistance of the water. So you can sometimes account for that. The other thing is sometimes in those large diameter pipes, you're already in a surcharge condition under most high flows. So the system is able to account for some surcharging, and the little bit of surcharging that you might add with a slightly smaller pipe diameter doesn't add up to be significant. But it is something to keep in mind for sure.
Speaking of lining, there's another type of rehab called CIPP that uses a bit of lining method, but it's fundamentally different. From what I understand, CIPP is usually used when there's infiltration of groundwater into the sewer. So they use that to kind of rehabilitate the integrity of the existing pipe to prevent I&I, as we call it in the industry, infiltration into that pipe and, prevent overloading that pipe with flows that you don't want to get into your pipe.
Yeah, CIPP is a cured in place pipe. It's definitely the most common trenchless rehab, especially for small diameter pipes. It's getting used everywhere, and it has a lot of pros and very few cons, I think. It's essentially an inverted felt bag that they soak in a epoxy type resin that then they use steam or hot water to turn it inside out inside the pipe. So they start at one end of the pipe, they blow it in, it turns inside out, and the pressure of the steam or the water holds it to the outside of the pipe. At the same time, that heat from the steam or the water cures the resin and hardens it, so that it essentially turns into a brand new hard pipe that can carry the soil load and the structural load of the pipe all by itself inside of that old pipe. And they send up machines that can recut the service connections. So if it's a collector along a residential street, they put the sewer liner in. You do have to ask people to stop flushing for a little bit on this project because it will back up because they're plugged for an hour or two. But they go in and they recut those holes open. Once the holes are cut open, the work's done and the sewer's back live again. So there's absolutely zero digging. It's just a few trucks on the surface. They do it in a few hours and they move on to the next one. And so most people will get their sewer lined while they're gone at work and they'll never even know it happened, other than the door hanger that says, hey, don't flush for this time period. So really a neat product and a great way to extend the life of our sewers. We see that used a lot. And there's even some new technologies out there that are UV cured rather than steam or hot water cured, which have some added benefits of flexibility of putting in and taking out before it gets cured. And that's some new technology that's currently getting out there that has some benefits as well. I do have a different webinar presentation that we've done on CIPP. So if you're interested, feel free to check that out. And then there's another technology for rehabilitation out there that's been around a while, pipe bursting. This is one that's kind of like slip lining. It's one that gets tossed out there as an option, but then never really comes to fruition. But Patrick, have you done any pipe bursting?
Coincidentally, they're starting a project out in Robbins, Iowa this week with some pipe bursting. It's very similar to slip lining in that you're utilizing an existing pipe as the alignment for a new pipe, but where slip lining, you're pulling a smaller pipe through the existing pipe. Pipe bursting, you're pulling a bigger or same size pipe. And where the bursting in the name comes from is when they pull the pipe back, it will cut open and destroy the existing pipe, making way for room for the new pipe that's following. But essentially, what we're using this project for is we're expanding the capacity of Robbins Trunk sanitary sewer system. So they had a 12-inch, which could do about 1.9 cubic feet per second, but we're pulling through a 16-inch. So they're effectively doubling their trunk sewer capacity to 4 cubic feet per second.
So that's a trenchless where you're actually increasing that capacity and have the option to go with a bigger pipe size, which would be different than all the other rehab projects that we've done.
Yep. And the reason why we chose to go with pipe bursting rather than just open cutting or a more typical method was in that sewer easement, several residents had installed fences, sheds, landscaping, not to mention existing electrical and communication lines. So it was a really messy area. So I looked into it and saw that pipe bursting was an option we could do. So even though the residents built their fences and sheds within an easement and the city is perfectly within their right to tear it down in the names of infrastructure, we decided to be nice. And at the end of the day, everyone's going to be happy. The city's going to have a brand new, bigger sewer pipe, and the residents get to keep their flower bed and utility shed.
Nice. I've heard that there's some limitations on what materials can be burst. I think cast iron pipe or steel pipe would be ones that maybe couldn't be, but I know for certain that clay tile pipe you could burst. I'm curious to see how that comes out for you, Patrick.
Definitely. And one more thing on the pipe bursting that we had to look into was there's kind of poor records of the existing sewer and services, and we weren't sure if there was anybody hooked up onto that. So we had to do some sewer televising to make sure we weren't going to blow up someone's service when we did the work. But luckily there was nothing on there.
Yeah, so something to think about when using that technology is being able to rehook up any services that are along the way is going to take some excavation more than likely. I think one thing though, on the sewer rehab, we tend to focus on the pipeline, but there's also the manhole accesses. And depending on what your goals are, and I always say this when we look at rehabilitation, what's your goal? Are you looking to restore structural stability of the pipe? Or are you looking to stop I&I? That can play into what technology you use. But one thing that often gets overlooked is the manholes, which can be a source of I&I if infiltration inflow is one of your concerns. So there's some technologies, some products and methods out there to line manholes as well as the pipe without doing any kind of digging. So you can leave the old manhole there, you can get a new liner in it, you can coat it, you can cast in place a new concrete one inside the existing manhole. Polyurethane liners, plastic liners, there's lots of different options out there, but something to always make sure that when you're evaluating your pipeline to evaluate the manholes too, because it would stink to put all that money into the pipeline and then realize that you haven't issued the manholes too and hadn't been planned for. In my experience, when you end up having to do manhole rehabilitation, it's only about 10 to 20% of the time versus when you're doing the sewer work. Usually they're in pretty good condition, but we have run into some pretty crazy poor old brick manholes. Sometimes they just can't be rehabbed. It goes through quite a bit of the trenchless technologies, and we touched on some of the more basic ones. There's still other ones out there, especially with rehab. There's some other up and coming trenchless new construction technologies, some laser guided stuff. It's definitely a moving industry, but all towards the goal of being able to build new or rehabilitate the old stuff to get it like new, but at the same time, limiting the impact, both cost-wise for surface features and also the intangible impacts of disruptions to properties, to trees, to driveways, streets, traffic, anything that's on the surface to avoid that and the benefits that come along with that. So Patrick, anything else thoughts you had on limiting impacts by trenchless methods?
I don't have too much to add, but I do like seeing trenchless in the field because if no one even know the project happened in the first place, I consider it a success.
Yeah, and then sometimes you have to make a mess, but sometimes it's really nice to not have to make a mess. And if you can get it done and keep the property owner happy because you're able to save their tree or their fence or their backyard or their access and not have to park a block away every day for a month, that's a good win in my book. So it's nice to have these options to be able to do that when we can.
Definitely. All right, Wes, I think that wraps it up for our discussion today on different trenchless technologies. If anybody listening to this has any inquiries on how trenchless installation of pipe can benefit their community, feel free to reach out and we'd be happy to help.
Yep, definitely. Thanks, Patrick. Nice talking with you.
Yes, nice talking to you. Have a good day.
Thank you for listening to Snyder & Associates podcast series, a civil engineering planning and design firm focused on thinking beyond engineering to improve the quality of life within the communities we serve. Find content related to this episode on snyder-associates.com.